Hey there, everyone. Welcome to Callaway Talks. I'm Dave, joined today by Dr. Alan Hocknell, our head of R&D. New year, new logo, new music. What do you think, Doc?
Look at all this. You're going up in the world, going places.
Oh, yeah. I don't know about that. But this is the show where we get to dive deep into product. You're the right man for the job. And I'm so excited today because we're talking about the Mavrik line of drivers. Mm-hmm. I feel like we've been working on this thing forever, between the tech and getting the shafts and testing it on tour and teasing it on social media. Is finally here. And I guess we got to start with the name. What does Mavrik represent to you?
Yeah, that was a bit of a rallying call to ourselves. You know, we've been pretty successful with drivers over the last couple of product cycles. And it was an internal call to sort of really think big, think differently, try and upset our own thinking. Go and do something special and behave a little bit like Callaway. You know, he was a bit of a maverick thinker way back at the beginnings of the company here, and we thought that we should behave that way too. Should we take a strong step forward?
And people think, of course, that we can't spell because we spelled it Mavrik, but that was purposeful as well. It fits very nicely on the bags, and it allows us to trademark and really own it. This driver is all about maverick thinking, about unconventional thinking, and when you talk about that, you got to start with the face. So we've got this flash face SS20, and we got a deep dive into the face and talk about what that's all about. First of all, just go back in time to a year ago where we were with the first flash face.
Yeah, that was the first time that we'd used artificial intelligence type techniques to help us understand a bit more about driver face performance. And to be honest, we were at the beginning of a probably fairly lengthy journey in discovering what's possible using AI in golf product design. Epic Flash was a great example. It showed us that things that we could do differently in the computer when we actually made the prototypes of the things that the artificial intelligence system was suggesting to us, they actually did have performance advantages. It got us very excited, and that became Epic Flash. A year on, we've had a lot more time to understand how to effectively ask more difficult questions of that system, how to develop that system further so that it's more capable than before. We can optimize around a greater number of variables, and it gives us a much greater amount of control over the design. And obviously the whole objective is to create more ball speed while staying conforming to the rules.
So where we were last year, we talked a lot about this 15,000 iterations, and it allowed us to prototype so many more faces than we could previously. But we basically tied up the supercomputer for almost a month. Now, a year on, you've more than doubled the investment there. And what has that allowed us to do with each of these unique faces?
Yeah, we were definitely encouraged by what we saw in Epic Flash. We've, as you say, doubled the size of the supercomputer. We've added some people with expertise from well outside of the golf industry as well to really take our understanding of that area much further, effectively giving us a really effective design tool now, where previously it might have been considered a research tool that was still very much in the early stages of development. Now we've got a really strong product design tool, and we can exercise it much more aggressively than we did it just a year ago. We can ask more difficult questions. We're not so much talking about how many iterations it takes, more about how much more efficiently we can use it and how much more difficult optimization we can actually achieve.
So I'm looking at one of these faces here, and there's so many different bumps and ripples, and then you pull up the one and you get the one for the Max over here, and that's completely different. So how do you guys figure out what is the parameters that you want for each of the different models?
Well, that's a good example of the step forward that we've taken in just a year. Maybe Epic Flash was really about peak ball speed. Now we're looking at optimizing ball speed around a larger area of the face. We're looking at controlling the way that different faces respond to different types of players as well. The Max model is for a totally different player type than, say, a Sub-Zero model. So it stands to reason we're going to give the computer different inputs, and the optimization of the face will be different, and therefore the face thickness pattern is different for each particular model that we have.
So an unconventional face looks totally different. It kind of required us to use unconventional materials. So just talk about what we've done to upgrade the materials in the driver face.
Yeah, that's right. We're obviously pushing the face harder to work harder during impact with the ball. That's how we get more ball speed. But that puts greater stress on the material. It deflects more during contact with the ball. And, we need to find better materials in order to withstand those stresses, impact after impact, right the way up to tour player speeds. So we've been using upgraded materials in the titanium category we haven't used before in commercial product, heat treated to higher strength levels, gives us the ability to take that AI design and actually make it real and make it survive in the real world.
So this FS2S titanium, exotic material, lighter weight, flexible, stronger, but a key thing I think is also the tightness of the tolerance around the CT. So talk a little bit about that.
Yeah, that's right. I think it's no secret to some people. We had a CT creep kind of phenomenon that was seen particularly on tour last year, and we studied that using that data and figured out how to use both the AI design tools to minimize that creep potential, and then use the materials themselves also to stop the face from moving during use or over repeated use, particularly at high head speeds. So we've done a lot to improve all that. That allows us to take our CT band, if you like, that we get in production, which is pretty narrow, and shift it even closer to the limits that we're allowed to use by the USGA.
So when I look at this and I see that flash face SS20, I know we're going to get a lot of questions out there. What does the SS stand for? So super strength. We're talking about drivers in this episode. We have other episodes on the hybrid and the fairways as well, but this is kind of that overarching category of, because we're using AI, we're almost required now to use these super strength materials.
Yeah, that's right. This material does give us the opportunity to take that AI design and make it real, deliver those ball speed advantages. Of course, the face works in tandem with our jailbreak technology, so we're getting more ball speed for a given CT, and that's a key characteristic of the Mavrik driver.
Yeah, and that's critical. So we still have the jailbreak system, and that's connecting the crown and sole together, making the face work extremely hard. We've also got this thing that we've talked about with Mavrik. It's another way of Mavrik thinking, this idea of unconventional forgiveness. So just let's dive into that a little bit. What would you consider to be traditional forgiveness, and then how are we doing something different here with Mavrik?
Yeah, the conventional wisdom, I think, over the last few years, if you're going to build a very forgiving driver, you need a large driver body. And the reason for that is that you want to put a lot of weight around the perimeter, and you want that perimeter to be as far away from the center as possible. So that generates large moment of inertia, or MOI, and that has been considered the sort of pathway to forgiveness. We definitely had drivers like that along the way. Rogue was a good example of that. But those drivers do come with some drawbacks. One of them is an aerodynamic drawback. So when you're swinging the golf club, that larger head actually takes more force to move through the air, particularly in the final third of the downswing. And the aerodynamic drag is greater, and you either have to swing harder, or for the same swing type, you're going to end up with lower head speed on arrival at the ball than you otherwise might. And we wanted to sort of explore that trade-off that we are forced to make, and ask ourselves, well, using our unique AI tools, do we have a new way of thinking about driver head design, not just about the face, but about the whole head, that could actually allow us to, for the first time, free ourselves up so that we get forgiveness and head speed and all the ball speed that we're excited about from the face.
So we throw around these words a lot about ball speed robustness and ball and spin rate robustness. Tell the viewers, what does that mean, and how are we achieving that in the new Mavrik driver?
Yeah, those are sort of R&D speak terms for forgiveness. So it's a measurable quantity. So if you take the idea that your impact from the center of the face might be ideal, then we want to minimize the variation from that behavior if your impact location moves off center, and it will. All of us hit off the center of the face, some by more distance than others, more regularly than others. So we want to minimize the variation in both speed and spin when you don't hit the center of the face. We want it to be as similar to the center of the face as possible. And we call that variation the robustness. If the robustness is high, there's small variation between the center impact and your other impact locations.
So we've been able to have that high ball speed robustness, but also with how you position the center of gravity, the spin rate robustness is excellent on this driver as well.
Yeah, the way that we uniquely go about the design of this driver to get this unconventional forgiveness is that we get a lot of that ball speed robustness that you normally get from the high MOI and the rearward center of gravity of a big driver head. We actually get that from more of it from the AI design of the face. The face speed robustness is higher than otherwise would be. That gives us the freedom then to put the center of gravity nearer the face than you otherwise would, and that actually improves the spin robustness property of the head. So suddenly we've got high peak ball speed, we've got speed robustness, we've got spin robustness, and we've done it without resort to a very large driver head, because we don't need the large driver body for large MOI numbers.
And that leads us right into this cyclone arrow shape. This is not a shape I've ever seen from a Callaway driver. I don't think any driver that's been on the market. Hold that up for the camera there for a second and just show that one a little bit in terms of what's going on with the arrow shape. And I think we have an epic driver outline versus the new Mavrik. So how does that help us with drag and club head speed?
Well, you've heard us talk about aerodynamic drag and the importance of it in other drivers before, and we've focused a lot on the airflow of the leading edge of the driver here. But we've had to look at that because we still needed a lot of weight low and to the rear of the head. So we needed a lot of body down in this part. And you can see in the cyclone shape here, the crown stays higher for a longer distance from the front to the back of the head, and the sole effectively comes up to meet it. So there's a big part of the recently traditional conventional forgiveness type shape that is just missing. It doesn't stretch as far front to back, and it doesn't have that low rearward tail as well. So once we free ourselves up from a requirement to have that, this shape is way more aerodynamically efficient in the passage through the air, especially in the complicated part where the driver head accelerates and rotates rapidly on arrival into impact.
So I saw some numbers: 60% less drag than Epic, 68% less drag than Rogue. What is that going to translate to for the golfer when they're actually swinging the club?
Well, at average head speeds, we're talking about a mile per hour of extra head speed on arrival at the ball, and that is a really good thing when you turn that into ball speed, especially with a head that is as speed robust as Mavrik is. So even if you don't quite hit the center of the face, the vast majority of that additional head speed that you're achieving is translated efficiently into ball speed.
The performance is amazing of this. The tour players have been raving about it. Obviously, we got Xander Schauffele was the first one to put it in at the President's Cup. He absolutely loved it. Another thing we focused on big time in this driver is the sound and the acoustics, and just going beyond using AI for the face, now applying that to the actual head and the acoustics. I think you've got the Max model over there. So talk a little bit about how that process worked.
Yeah, this one's a good example of the three because it shows the end product has ribs inside of the head, which we use conventionally for controlling sound, but it has one in a particularly unusual place right down here, sort of diagonally across the center of the sole. And that is a product of us using our AI tools to design the sound of this driver. Effectively, we were given objectives to eliminate certain frequencies and shorten the duration of the sound and promote other frequencies in the sound as well. And doing that with a finite amount of titanium that we allowed it to use. Given all those objectives, it had the entire inside of the head as it limited solution space to start with, but it very quickly converged on an idea of some ribs around these weight ports, which is, somewhat conventional, but then certainly putting it in some of these other places, not something that we would have come up with ourselves. And as you say, a lot of people have been commenting really positively about the sound of all three of these models as they've all gone through that same process.
And we've got up here a little spectrogram chart. If you can pull that one up, Sean, just talk through a little bit. We've got the Epic Flash on the left, and then the Mavrik on the right. What are we looking at here, and what were we seeking to kind of improve on the sound?
You said this was going to be a deep dive.
Yeah,
here it is.
Yeah, there we go.
So these are two pictures of sound. The one on the left is a picture of the sound of impact of Epic Flash, and the one on the right is Mavrik. So across the horizontal axis, that's time. It's only about 50 microseconds from left to right, so it's a short duration sound. Frequency is on the vertical axis, and then the loudness, if you like, is represented by the color. So you can see in Epic, there were two particular frequencies that lasted longer than the rest of the sound, and those were the problems. They were the things that people fed back to us. They didn't know that was what it was, but there were parts of the Epic sound that they didn't like, and this is a picture of that, the part that they didn't like, essentially. And compare that to Mavrik on the right, the same scales. The sound, you can see some of the problem frequencies have been addressed, they've gone away, and we've promoted some of the other, and the duration of the sound is overall shorter as well. So a much higher quality sound on the right than on the left.
But that just kind of goes back to this idea of Mavrik thinking, of doing things in unconventional ways, of applying the artificial intelligence now to the sound. And
Yeah.
I think there's a lot of people out there who think that the sound is what it is, and there's no engineering going into that, but that's not the case.
Yeah.
There's a lot of work on that.
Yeah, we've been working on sound for quite a while and improving our simulation tools and our measurement tools, but this is the first time we've really been able to exercise it in such a thorough way, such that we can look at the duration aspects more clearly as well, and obviously the optimization tools applied to it really take us to the next level.
So we've got three drivers. We've got the standard model, we've got the max model, and the Sub-Zero. So I want to go through each of these in order, and we'll just talk a little bit about who they're for, because I'm sure a lot of people who are watching out there want to know, which one should they be testing out, which one is right for them. So starting with the standard model, we talked a lot about that. So this would be our fastest head, right?
That's right. This is the fastest head, and this is also the one sort of in the center of the market. It will fit the vast majority of players. It's the one that has a sort of mid-CG height, semi-draw bias, some of the characteristics of Callaway drivers that have been very successful over the last few years. The vast majority of players will fit into this one. They'll hit it with the highest ball speed most consistently, and it will go the furthest and have a great downrange consistency as well.
Yeah, so the standard's going to fit a majority of golfers, but we also have the Sub-Zero, and this has been extremely popular for us in the last few iterations, this idea of high MOI with low spin.
Yeah.
But over the past year with Epic Flash, which was the #1 driver out on tour, we learned a lot. So talk about how we've incorporated that into the shaping of the new Sub-Zero.
Yeah, I think for a while on tour, there was a big drive towards high launching and lower spinning types of objectives. I think the tour has backed off of that a little bit, looking at the conversations we've had with a lot of our staff players, a lot more at the start line of the ball, and then whether the ball falls left or right in the final third of the flight, and really controlling that flight at their higher speeds is a primary objective. And some of the shaping of the head actually has a subtle influence on those things. So the new Sub-Zero shape, it does have that lower spinning but still high MOI or high forgiveness type characteristic, but it also incorporates some subtle shaping elements that we've taken from the variants of the driver that we've had out on tour.
And you have that front back weighting, so you can control the spin as well, about 200 to 300 RPM. So the Sub-Zero, typically for the better player, but really for that player who wants to eliminate a lot of the spin. And then we have a new model. This is one I'm really excited about. It's the max model. I feel like this is almost like two drivers in one. So talk about what the max is all about, what we're trying to do here.
This is a driver for the kind of golfer that needs the most help. So the most help because they might use the largest amount of area of the face over the course of of a round or several rounds. Most help because they need the most draw bias, because they fight a fade that becomes a slice, or they might need help in the form of greater launch angle than you otherwise would get, people who struggle to get the ball airborne. All of these are important errors that we can correct for using the Max model, and it's a very, like you say, a very complete sort of driver, the type that we haven't had before. It has 2 screws in there. If you put the heavyweight in the heel, you get all of that shot straightening kind of characteristic, but if you put the heavyweight in the back, you get higher launch angle, and you get one of those conventional forgiveness, high MOI, large body drivers. And for some players where head speed isn't necessarily a primary objective, maybe they're slightly slower in the swing speed range already, the advantage of having the larger MOI and the ability to launch the ball a little bit easier from having a rearward center of gravity is actually the right configuration of driver for them. So in the course of a fitting, usually you'll be looking at 2 of the 3 of these drivers and be able to experiment a little bit with both.
So we get the question about the sliding weight track, and we had that with Epic. We don't have that now, but now we have 3 different drivers. You were saying that you feel like Mavrik can fit an even wider range, and why is that? Yeah,
a sliding weight track still has its place. It gives a very detailed fitting, but it is only really addressing one variable, and that is draw bias, so that left-right shot shape correction and optimization for any one player. That does have its place, but instead of that in Mavrik, we've used the weight differently with 3 different heads, and because the 3 different heads have such different characteristics, we do address the swing issues of a much broader range of players, including things like launch angle, wide distribution of impact locations all over the face, and in the draw version of the Max, we create more draw bias than we can using a sliding weight system. So effectively, using all 3, I think we, as a system, we have a more complete solution.
One of these drivers is right for you. You just got to go out and get fit and find out which one it is. Of course, when we deep dive, we always got to talk about shafts. So I'll run through these relatively quick. But on the lighter end of the scale, we have the UST Helium shaft, which is really well respected as a lightweight shaft. Our up the gut is going to be the Even Flow Riptide, which is a new shaft that Project X has launched, a new version of the Even Flow. And then on the Sub-Zero side, we've got the Rogue White, the 130 MSI. So a really, really stout offering. And we always try to make this driver very, very premium. So we're going back to the Align grip, and that's been very successful for us.
Definitely, yeah.
So 3 models. The big story here, AI, speed, but obviously a lineup that you guys in the R&D side have to be extremely proud about.
Yeah, that's right. There's an awful lot of work that goes into any product line, but this one in particular, it takes something that was very new to us just a year ago and really builds on it in a very strong way, using those AI tools that we believe are unique to us in the golf industry. We've invested in that, and I think the Mavrik line really shows the rewards of the next stage of our development in using AI to deliver genuine performance.
I'm so excited for people to go out and try this. We've been working so hard on it. Huge shout out to yourself, Evan, the entire R&D team of what we've come up with for Mavrik. Really, really an amazing achievement. We said we were going to go deep. We're going to do a deep dive. We even brought up the spectrograms. So we went deep, but that's going to wrap it up for us today on Callaway Talks. I'd like to thank my guest, Dr. Alan Hocknell, our producers, Sean, Trevor, and Daniel. Thank you guys, and we'll see you next time on Callaway Talks.